Yeah, my name is Alexander Infuhr. I'm a student from Austria. I'm called on Twitter InsertScript. I'm a pen tester for Q53, and I'm mostly interested in browser security and web security and files which are automatically loaded in the browser. Yeah, when I first started this research, I had no clue about PDF actually. I just know it could do some stuff. It's not just text and pictures, but I had no idea. And I also I didn't want to find memory corruption bugs. I mean, I found 3 on accident, but I did not find them on purpose. And yeah, so I started to get all the references I need. I mean, this is just a selection. It's not all of them. And as you can see, if you want to, you can read the whole year to understand the stuff. Especially the specification just for the forms you can put into PDF is larger than the PDF reference itself. So, and you will see why, because it can do quite a bunch of stuff. The lifecycle designer scripting reference is also a separate reference just for JavaScript. So there are 2 different JavaScript APIs in PDF you can use. And there is FormCalc, which is a really cool language, which is not really well known, and I'm going to show you what it can do. Yeah. First, we'll talk about a little bit of the structure, but we'll just a really short introduction. Then we'll talk about some protection which are in place, what we can possible attacks, also some not patched vulnerabilities. Then we'll talk about how you can load a PDF in your website when you don't allow to upload a PDF, and just to show it. And in the end, I'm also showing some defense mechanism you can use to protect yourself. Yeah, people who know Ange, he loves to do file formats and make pretty pictures of it. And he also did it for PDF. He also did a great talk about the structure and all, how you can, what the streams are built of, and all about the switches you can use. There are so many. And if you're interested in that stuff, watch his talk. It's like 1 hour. So let's start. At the beginning, you have the PDF header. It's not enforced at offset 0, so it can be in the first 1,000 bytes. Also, there is in the reference, if you read the specification, there are 2 PDF headers, but this is the only one working. I don't know why the other one isn't, but it's quite funny to know. Then you need the trailer. The trailer can specify a lot of stuff, but it's basically used to specify the root object, which basically is the starting point of your PDF. And as you can see, objects are always referenced by the first and the second number. The second number is like a versioning system, but I never used it. It's always 0. Yeah. Then you need the root object. The root object can specify actions like open action, which basically tells PDF as soon as the PDF is open, go to this object and execute the action you specify there. There are also other actions which are called alternative actions, where you can say, yeah, when this page is printed, do stuff, when it's opened, when it's closed. And that's the way how you can execute stuff. This is a typically structure of a handmade PDF with some text. As I already told you, if you want to know what all the switches do, watch the talk of Ange. So, and this is basically an object you could use for open action. The first one would say, okay, we want to execute JavaScript. In this case, it's just a simple alert box, so it does nothing really interesting. Another one is the so-called URI action, which tells PDF, yeah, when the PDF is opened, I want to go to this website. So when you load this PDF in web browser, this URL will get loaded automatically. There are also other actions like the famous launch action, where you could execute external programs. which was then dropped because it was used for malware. And there are also other ones like called go to E and go to R, where you can also specify a location where you want to go as soon as the PDF is opened. And you will see you can do some funny stuff with this. The protection in place is actually not really difficult to understand. For cross-site scripting, there's a big blacklist of protocols, like, of course, JavaScript for BaseScript, but also a lot of other protocols. It's quite big. For local file access, there was privileged JavaScript, and they almost dropped the support. You can still execute privileged JavaScript, but you have to have the possibility to write in a local JavaScript file in the file system in a special folder. So it's not that interesting as an attack vector anymore. Yeah, for the web context, it's also, as long as it's same origin, there is basically no protection. It's, if you want to access a document via PDF, and as long as it's same origin, it's always okay. And the last are signed documents. I haven't looked into them yet. You can sign a document and give them special rights which it needs, because there are special functions which only work in Adobe Reader Pro. But if you sign them and mark this, hey, I need this right, then suddenly it works in Reader 2, in the simple standard Reader 2. But if you don't sign it, just say, no, I don't support it. And you can, there are some really powerful functions you can use when your document is signed. So let's go to attack vectors. I'm going to show you actually how you can still execute JavaScript via PDF, although they try to block it. Also talk about form calc, then a possible header manipulation, and some external entity attacks are found. So cross-scripting is basically possible because PDF can change the location in a lot of ways. It has native links, like standard links you know, then it supports a subset of XHTML, where it also supports the A tag. JavaScript can change the location, all kind of submits can change the location, and actions can also change the location. And they had a lot of bypass in the past, and I thought it's protected, or I didn't find one. But there is one pitfall if you load a PDF, a attacker-controlled PDF via embed or object. It's possible to execute JavaScript in the embedding page. So you can change the location. The PDF change the location to JavaScript colon alert location or whatever, and then it's executed on the embedding page. And I'm going to show you this now. It's quite funny. Yay. So, do we need the magnifier? Do you see it? Go away. Can you actually read stuff here? Yeah. Okay. Yeah, with people in the back. So, okay. Just easy. So I'm just going to load this HTML, which loads attacker.com, go2e.pdf. And in go2e PDF, we have an open action, which specifies object 7. And as you can see, I use an action called go2e and specified JavaScript handler. And you will see that it will alert the location of the embedding page, or at least it should. If my is still working, I think I have to restart my EA. Yeah, that looks good. Okay. Okay. Hopefully we don't lose the left remaining screen too. So if we say like victim.com, it will load the PDF from attacker.com, and as you can see, it executes the JavaScript in victim.com. So never embed attacker-controlled PDF via embed or object. Just assume it's a Flash file, then you won't do the same, hopefully. So let's talk about the form call specification. That's a really cool old language. It was specified in 1999, and its roots are in the electronic form software from Adobe and common spreadsheet software. Basically, you can use it in the forms. In forms, you can the so-called XFA structure. You have the date. It's one big XML structure with the data, the form fields, some configuration, and you can also specify events you want to execute. And these are all the functions it supports. They're like arithmetic, date, financial, logical, miscellaneous, and string. And they also have all built-in functions. And they're really interesting because the first one is a get function. It's just one parameter. You specify a URL, and it retrieves the content and gives it back to you. And also, this is done by using the browser, so all session cookies are sent along. This also works with post, and you can even create a put request. And that's basically how a structure looks. There's a really simple example from, once again, from Orange. So it's quite easy to test and play around with it. It's like XML HTTP request in JavaScript, but I think it's even easier than this. And the cookies are sent too. And if you think malicious, you get a user to view your PDF, let's say you upload it on Facebook, then you could actually read the whole Facebook page in context of the logged-in user. So that's actually quite powerful. And the steps are easy for an attacker. You just upload a PDF to the domain you want to attack. Then you get the user to visit your page or get him to open the PDF. And then the loaded PDF is in the origin of the page you want to attack, and then you can just read any site you want. So hopefully I can show you this. So once again, I have a HTML file. So the user is going to view this HTML file. It's loaded from victim.com, steal the target PDF. And I created a PDF which passes the target parameter and then fetches it, passes it on to form calc, retrieves the content, gets it back to JavaScript, and then alerts it. And in this case, it tries to read from the same domain, so we won't get any alert boxes to ask for the user to permission. And we're going to read the secret file secret, which is really interesting. No, not really, it's just some random stuff. So hopefully screen is, yeah. I don't know what's going on. If we now load this, attacker.com. Hello? Okay. Load target. Now in the background, if I don't want to start normally I would show you the request, but I'm scared then you won't see anything at all. So basically what's happened now is the attacker page loads the PDF from victim.com and tells him to get this file or whatever from victim.com and retrieves the content. In this case, I'm just alerting it. Normally, you would send it to the attacker server and do whatever you want with it. The really scary stuff is you can actually, yeah? It always works when you use the PDF plugin from Adobe. That's necessary. Yeah, assume it's the plugin, not the browser who's doing stuff. But I'm mostly tested on EA because that's the standard installation. Most people use different views in Mozilla or Chrome. So, the funny thing is with this feature, you can read CSRF tokens if you want. It's also not a bug. I don't know if they're ever going to drop this feature. And it was first mentioned in 2010. Maybe someone knew it before, I don't know. It's from some Russian guys. Yeah. So let's talk about the same origin policy. It's like the same in Flash. There was a simple bypass in the past where I just used a HTTP redirect and suddenly you could read any domain. And just for fun, I used this in combination in form calc to create a man-in-the-middle proxy with PDF. But it's really slow because it's not intended to be used as a man-in-the-middle proxy, but just for fun. Yeah, as soon as you make a cross-origin request, you will see the request for cross-domain XML and if it's allowed or not. But if you use a redirect, it will send the request. You get the post request you sent, and will retrieve the content, but then you can't access it. So it's different from when you specify like cross-origin to Facebook. It will say no, that's cross-origin. But if you make a redirect, so before you go to your own domain, make a redirect to facebook.com, then it will actually send the request. But you can just you can't access the response. This is especially interesting because with form calc you can also specify any HTTP header you want. You can override all of them. Okay, not all of them, one not, because you can't specify the user agent. But you can specify everything else. So you can even set the content length header, which creates a really interesting problem. And yeah, you can also bypass, of course, any refer checks, host header checks, doesn't matter. The funny thing is when you change the content length to 1 in a post request, but have a big payload, the server mostly will recognize the remaining payload as a new request. So you have full, basically you can create a custom get, post, or whatever request you want to server. You won't get the response back, but if you ever need, I don't know, a really weird request, then you can build it with form calc. So then I had a look at external entity attacks, because there is XML parser in PDF, and it also parses a lot of XML. It's also bound to, as soon as you try to fetch any files with XML, it's also bound to the same origin policy. But the problem with external entity attacks is you can also use it on the local file system. So if you open a PDF from the local file system, then the origin is the local file system. Yeah, if you've never seen before how an external entity injection looks, it's basically you specify an entity name, like, I don't know, XXA in this case, tell its system, and then you specify the location where you want to get it from. If you specify in PDF doesn't support actually external entities, or at least they try to not support it. The first one, where I actually get the idea from trying, is from the paper Polyglots Cross-Origin by Crossing Formats. They found it in xmldata.parse. They fixed it. Then I found one myself. We are load XML. This was fixed in April. So I thought, hey, maybe I find another one. And of course I did, because XML also has the second language, XSLT, to transform the XML. And it's either loadable via XML style sheet, or via apply in JavaScript. You can just apply it. Yeah, because I was asked, I put it in the slides. PDF uses the Sablotron XML engine, if anyone knows it. It seems like a really simple XML language engine. And the interesting part here is actually XSLT can use external entity again, like in XML2. So it's like you just specify a really simple XML, then you parse it, and then you just define, transform it how you want. It doesn't matter. Just has to be valid. And you specify again an entity from, it again has to be the same origin, but you can specify, like, I don't know what you want to read, a JSON file or whatever, and pass it, and then it's passed back to the JavaScript, and you can do whatever you want with it. And this is if it's loaded, like I said, from the local file system, you could do the same with local files. Let's see if I can show you this. So, where is it? So again, I just use the open action. So in this case, we specify, hey, we want to execute JavaScript. And as you can see, the first line is just some random XML. And then we specify here that we want to read from victim.com this JSON structure, this JSON file. The problem with XML is it has either to be just text or a valid XML. There are some ways around this, but they don't seem to work, or I don't get them to work correctly with PDF, maybe the next days. And then we just pass. This is the function where the first one was found, the first XXA one. And then we just apply it, and we can read, once again, same origin files. Let's see if it's work. So, I think I have a file for this. Yeah. So once again, I'm just loading the PDF via embed from attacker.com. So once again, it's loaded from victim.com, and it uses this vuln to read like this really interesting JSON structure. Hey ho, www. Yeah. So, but there is another one, because you don't even need to use JavaScript, because the XFA is XML already. So it has to be parsed, and of course the same vuln is there too. But there is something really weird going on, because if you're trying to load a style sheet with the XML style sheet tag, suddenly PDF believes it's on a local file system and tries to find it on the desktop. And if you specify now a web page, and even it's the same domain where it's loaded, it will say, hey, that's a cross domain request. Are you going to allow this? Maybe it's harmful. And this dialog is really interesting. It tells you, yeah, you can allow it, block it, or cancel. And you can remember the decision. And it doesn't matter what you click, it always does the same. It sends the request. Yeah, in this case, this is not so useful. Yeah.
If you open this PDF, is the XML code executed?
Yeah. So in this case, it's you need an out-of-band technique to retrieve the content. Yeah, it's if you're familiar with XXA attacks, it's just a normal way to use. So I think it's the only one out-of-band technique I know to extract data, because this time we don't have any scripting capability, so we need to fetch the data into one variable. Then you create a URL to your own domain, and then send the request. So basically, in test we store the file we want to steal, and in the second file in send.ttt we create another variable called send, or all, which creates send. And if we want to retrieve send, it sends the payload to attacker.com. So, I'm at the time? Okay, way too fast. Okay, ways to load PDF. Yeah, basically there are two ways, or two common ways to do it. The first one is getting more and more difficult, or actually, because PDF doesn't enforce the header at offset 0, but they have started again doing blacklisting of certain headers, like all Flash headers, because they forgot one, but then they fixed it. Then all the JPEG headers, but they also had forgotten one way, and Ange found it. And then PNG, TIFF, I don't know, it's like a really big list. So if one of these headers before the PDF header, it will just say, I don't know, it's invalid PDF or whatever, and stops rendering. So this is not that interesting anymore. Another way is if you type in Google how to force download of a file, you will get Stack Overflow response with set content disposition header to attachment and the content type to application octet binary, I don't know. But this doesn't help actually, because you can just load it via embed tag and specify it's an application PDF. Then the browser will see, okay, I will pass this on to the Adobe reader, and he will just render it without any problem. So don't rely on this, because a lot of people don't believe that the browser will download the file, but it's not always the case. So, to defend yourself, I would say try to host content from user files on a subdomain or if on another domain, and use Xframe options header to just say, my files are just allowed to load to be embedded from the same origin or are actually never allowed, and the browser recognizes this header and then stops and says, this can't be embedded. And that's actually quite a useful way to block such attacks. For end users, you can either use a different reader or disable JavaScript. This also blocks form calc if you do this. If you enable protected view, it also stops all the external entity attacks. By stopping means it freezes to death and does nothing, and the Internet Explorer is also frozen, but it doesn't send the request. It also does some other stuff, so it's a good idea to enable it. It's not enabled by default, actually. So that was it. It was kind of fast, I think.
Right, questions, and as I've got the mic, I can hijack this, and that's my first question. So this is with the Adobe PDF reader.
Yeah.
Have you tried the Firefox PDF reader?
Yeah, it doesn't support JavaScript, nor they don't even think about form calc, so it's not.
So it's not vulnerable to these attacks?
No.
Next question.
In fact, I have two questions. When you are doing out-of-bound text extraction with AppSecEU, are you limited to the kind of data you can put in the final UI? Like limited to text, no new line, size limit, something?
New line, I think, is no problem. I haven't tried how much data you can actually transmit. I think it will be limited to the amount Internet Explorer allows, because it's using the browser to send it, actually. I don't think that the Sablotron engine enforces any restrictions here. So, but I haven't tested it so thoroughly.
Okay, so you're using the browser to limit the request?
Yeah, that's also the reason why it's sent the cookies along.
Okay. And the second question is, do you try to access the local file system or between origins using accessibility functions like documents, for example?
Yeah, but the same origin policies are enforced there too.
Okay, thanks.
Have you had a look at the differences, at the security differences between the Adobe implementation and Chrome's implementation? Because they claim to do some things better, yet they do some things worse, and it would be interesting to see like a table or at least like a list of features, what they do better, what they do worse, and what kind of applies to them as well.
I haven't tested for XML attacks. I haven't tried them yet. But in case of JavaScript, they have they pretend to support a lot of functions, but they're doing nothing. So it's when you try to enumerate objects, there are quite a bunch of them, but they don't seem to work or do anything. And you don't get any error response or anything. So.
I'm assuming you told Adobe about these things. What were their reactions?
Thank you.
So how long ago was that?
The newest one like some days ago, but normally I think that the other one's like 2 weeks ago. So, but it takes some time. It's always in the patch. They're not the fastest when it comes to patches. So I didn't want to wait that long.
So this attacks works only on the plugins or only on the Adobe application during the opening of file system?
It also works when you just open on the local file system with the Adobe directly, because it's no difference. In the browser, it's just passed along to the Adobe application, and on the local file system, it's directly started with the PDF. But there's no difference. It's just yeah. I think so. I haven't tested it, but I assume that it will work.
You said that you can override the host header.
Yeah.
Does it really override the host header of the browser, or does it add additional host header?
No, it overrides the host header.
You cannot override the user agent of the
No. I don't know why, but you can.
That's crazy.
Yeah.
Any more questions? That's cool.
Sorry, one more. In the defense section, you were recommending the usage of extra function settings. Now, more and more security goes into this one header, into this magic header that does everything. Yet at the same time, the header is supposed to be non-standard, and nobody knows how to handle this, so it's kind of like a ticking time bomb. And you would have to actually recommend to clients to use something where no one knows where it's going. How do you think this is going to end?
I would say it's easier for us, but I don't think in a point of security it doesn't make much sense. I would have seen some people suggested like additional header just to specify which plugins you want to load. So the website should could control which plugins the browser is allowed to load. So they can also put it in the magic header too, if they want. But I don't think it will improve much.
So in 5 years, you're going to have open positions for header managers.